Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, I will highly suggest and request you to kindly support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video I will start the chapter rational numbers from the textbook of RS Aggarwal. So let's start. This will be the class number 1 of the on the chapter rational numbers following the textbook of RS Aggarwal. So this video is part of the playlist CBSE Mathematics class 7 following the textbook of RS Aggarwal. In this video, I will discuss the introduction of the rational numbers which I have already studied in previous classes, and we'll discuss the properties and the standard form of a rational number, and then we'll solve few problems of exercise 4A from the textbook. So let's start. Okay, so on the left hand side I have my notes prepared for the class number 1 on the chapter rational numbers that I will discuss in this video, and on the right hand side I will do any kind of discussion, concept clarification, and will solve the problems. Okay. So what are rational numbers? Rational numbers you have already studied in your previous class 6. You know the basic definition of a rational numbers, and you have probably done addition and subtraction of rational numbers. So what are rational numbers? Rational number, a number of the form, a number which can be written in the form p by q, where p and q are integers but q is not equals to 0. These kind of numbers are rational numbers. For example, as you can see on the notes, minus 2 by 3, 4 by minus 2, 3 by 1, 0 by minus 4. Please note that 0 by minus 4 is also a rational number because 0 and minus 4 both are integers. So 0, essentially 0 is also a rational number. Likewise, you have more. I will try to give more examples of rational numbers. Let's say you can have okay, so you can have, let's say, 7 by 7. This is a rational number. Essentially it is 1. You have 7 by 1 is also a rational number. Let's say 4 by minus 4 is a rational number. So p and q will be any integers, but q should not be 0. That is the only condition. So any kind of all numbers where p and q are integers and q not equals to 0 are rational numbers. Okay. Now we have positive rational numbers and negative rational numbers. So in short I'm writing positive rational numbers. In short I am writing Rn. So what are positive rational numbers? Positive rational numbers are those rational numbers where both the numerator and denominator, that is p and q, have similar sign. That is, they are either both positive or they are both negative. Like 3 by 2, minus 1 by minus 6, like what else? 4 by 5. But remember, 0 is not a positive rational number, because even though 0 is an integer, so by definition rational number says p and q must be integer and q should not be 0. Now let's consider 0 by 1. 0 is integer, q 1 is also integer. It is a rational number, but is it a positive rational number? Is it a positive rational number? The answer is no, because 0, the integer 0 has no sign. 0 is neither positive nor negative. What are positive rational numbers? Positive rational numbers means q and p has to be integers having a sign. The integer 0 has no sign. So 0 is not a positive rational number. Now we can have more, like 121 by 100, anything. Both p and q must have same sign. Okay. So this is not a positive rational number. What are negative rational numbers? Negative rational numbers are those rational numbers where the numerator and the denominator are of opposite sign. Meaning, if the denominator is positive, the numerator has to be negative. If the numerator is positive, the denominator has to be negative. So they are of opposite signs, like minus 1 by 1, 2 by minus 1. But again 0 by 2 or 0 by minus 9, these two are not negative rational numbers. These two are not rational negative rational numbers, because 0 has no sign. The integer 0 has no sign. Okay, I hope it's clear. Positive rational numbers and negative rational numbers. Now, so you can understand that a rational number is of the form p by q. Okay, so now we have to understand that the facts that all natural numbers, the collection of natural numbers is denoted by the letter capital N. This is the collection of natural numbers or the collection of whole numbers, integers. All numbers are actually set, which you may not have studied up till now. I don't think set is even in the syllabus of CBSE board until class 10. You will be studying set definitely in class 11 and 12. So set is nothing but a collection of objects, and those objects are well defined, and they are distinct objects. So natural numbers, the sets are written inside curly braces. So this is curly braces. The first one is the opening curly brace. The second one is the ending curly brace. So you write all the you write all the and the elements of the sets are called its members. So the natural numbers are, we know that 1, 2, 3, 4, like this. And we denote, well, I will not go into the sets, but the collection of natural numbers, you know that 1, 2, 3, 4, 5, 6, 7, 8, and it's endless. They are the counting numbers, and we denote the set of the collection of natural numbers by the letter n. Similarly, we know, you have studied whole numbers. Whole numbers is nothing but the collection of natural numbers plus the integer 0. So you have 0, 1, 2, 3, 4, and so on. So this is whole numbers. Now, what are integers? Integers are nothing but the whole numbers as well as the negative of the natural numbers. So you have 0 and the whole numbers and the natural numbers like this, and this is on the number line. This is on the 1, 2, 3, 4, 5. These are on the right hand side of the origin. 0 is the origin, and on the left hand side you have the negative of the natural numbers like this. So this is the collection of the integers denoted by, and we denote it by the letter capital Z. You know up till this. Okay, you also know fractions. Well, I don't think there is any letter for the collection of fractions, but you know fractions. I'm making a, let's say f is the collection of fractions. So fraction is what? All those collection of the numbers p by q, where p and q are natural numbers, and q not equals to 0. You have studied this. I hope you have studied fractions and decimals in class 6. So these are fractions. A number of the form p by q, where p and q are natural numbers, and q not equals to 0, meaning numbers like, so the numbers like half, let's say 4 by 5, or 9 by 3, 100 by 500, let's say 121 by, like this, and so on. So you have fractions. Now rational numbers are nothing. Rational numbers, I'm denoting as n, Rn. Rational numbers are nothing but the collection of the integers, plus. Please do not consider this plus as a addition operator. I'm just saying that the rational numbers is the collection of the integers, that is z, the fractions, plus the negative of all p by q in f, that is all fractions that you have and their negatives. So the fractions, the negative of those fractions, the integers, these are the rational numbers. On the notes on the left hand side, you can see I have categorized the rational numbers as integers, fractions, negative fractions. Now, of course, the integers, this includes this includes whole this includes the whole number plus the negative of all natural numbers. So Z, the collection of integers, Z includes the whole numbers, natural numbers, and the negative of the natural numbers. Fractions include fractions are the numbers of the form p by q, where q is not equals to 0 and p and q are natural numbers. And so rational numbers is nothing but the negatives of the fractions and the integers. Now you will notice that fractions also include the natural numbers and the whole numbers. This is just a side note. Fractions also include the natural numbers and the whole numbers. Okay. So these now, okay. So you must remember that. So from this discussion, we can say that every integer is a rational number. See, every integer is a rational number. Every fraction is a rational number. I have not mentioned this in the notes on the left hand side, so I will just write it here. These are very important concepts. That every integer is a rational number. Every integer is a rational number. Why? Every integer is a rational number. Why? Because p by q, every integer is a rational number. How can we say this? When we can represent every integer n, let's say n is an integer, every integer n, we can represent it in the form p by q, where p and q are integers and q not equals to 0. So definitely we know that n equals to, we can write it as n by 1, and so it is of the form p by q, q not equals to 0. So every integer is a rational number. Since every integer is a rational number, of course this will mean that every whole number is a rational number. Also, every natural number is a rational number. So Every integer is a rational number, every whole number is a rational number, every natural number is a rational number, and finally every fraction is a natural number. Every fraction is a natural number. No, every fraction is a natural number. Okay, and of course, the negatives of the fractions are rational numbers. Okay, now let's understand the properties of rational numbers. So, if p by q, let's say p by q is a rational number, and m is a non-zero integer, then we always have, then if we multiply both the numerator and the denominator by m, the rational number remains the same. That is, p by q equals p into m divided by q into m. So, here we are multiplying both p and q by m, where m is a non-zero integer. So, for example, if we have any rational number, let's say 4 by 5, I can multiply it by any integer. Remember, I am multiplying it with any non-zero integer. It cannot be 0, and I will have the same same rational number. So, let's say I can multiply by -1. Both the numerator and the denominator has to be multiplied by the same number. So, this is -4 by -5. They are same. They are same. Also, I can multiply them with 5, both the numerator and the denominator, and this becomes 20 by 25, and they are same. They are same. The second property says that similarly, if we divide for a rational number p and p by q, if we divide both the numerator and the denominator by a non-zero integer, the rational number remains the same. So, let's say we have 6 by 9 is equals to, if we the number by which we are dividing has to be non-zero integer. So, let's say, so we can divide both the numerator and the denominator of the rational number 6 by 9 by 3. We can do this. We can do this, and this becomes 2 by 3. So, 6 by 9 is equal to 2 by 3. Earlier, 4 by 9 was equals to -4 by -5, that is equals to 20 by 25. Another example, let's say we have -14 by, let's say, 49 is equal to, I can divide both the numerator and the denominator by -7. I can divide both the numerator and the denominator by -7, and it will remain the same rational number. So, the numerator becomes 2 and the denominator becomes -7. They are same. So, -14 by 49 is equal to 2 by -7. They are same. Why they are same, we will discuss later, but they are same. So, when you multiply or divide the numerator and the denominator by a non-zero integer, the rational number remains the same. Okay. Now, equivalent rational numbers. Two rational numbers are said to be equivalent if one rational number can be written from the other by multiplying or dividing the numerator and the denominator by some non-zero integer. So, let's say you have a rational number 5 by 8. Now, I multiply this rational number. I know that if I multiply both the numerator and the denominator of this rational number by 4, I get, what do I get? I get 20 by 32. If I multiply both the numerator and the denominator of the rational number 5 by 8 by 4, I get this. This is nothing but 20 by 32. So these two rational numbers are equivalent. They are equivalent because I have obtained 20 by 32 from 5 by 8 by multiplying the denominator and the numerator by 4. So they are equivalent. Similarly, let's say I have a rational number 16 by let's say 24. 16 by 24 I have a rational number, and what I do is I divide both the numerator and the denominator by say 4. Say 4. Divide by 4. This is divide by 4 to both the numerator and the denominator, and you get 16 divided by 4, 24 divided by 4. This is 4 by 6. So these two rational numbers are equivalent. Because I have obtained the rational number 4 by 6 from the rational number 16 by 24 by dividing the numerator and the denominator by 4. So this is the meaning of the definition of two rational numbers to be equivalent. That is, you can obtain one rational number from the other by multiplying or dividing with some same non-zero integer. Now, okay, so now when are two rational numbers equal? Let's say you have two rational numbers, let's say 4 by 3, and we have a rational number, let's say 5 by 6. How do we know? How do we decide? How do we know that they are equal? Now, given two rational numbers, like in this example 4 by 3 and 5 by 6, how do we decide? How do we find that they are equal? We do by doing cross multiplication, cross product. This way, we multiply 4 with 6 and we multiply 3 by 5. If 4 into 6 is 24 and 5 into 3 is 15. 15 is not equals to 24. This implies this is a symbol, means this implies, or this means that 4 by 3 is not equals to, this is a symbol of not equals to 5 by 6. So we do cross product. If you are given two rational numbers, you do cross product like this and you check the two products. If they are same, then the two rational numbers are same. If they are not same, then the rational numbers are not same. Let's say I have let's say minus 1 by 3, and let's say I have 3 by minus 9. Now we are asked if the rational numbers minus 1 by 3 and 3 by minus 9 are same or not. So what do? We do cross product like this. So we get 1 multiplied by minus 1, and the other product is 3 into 3. Now, so this is 9 and this is 9, they are equal. So this implies minus 1 by 3, the rational number minus 1 by 3 is equal to the rational number 3 by minus 9. Now, two equivalent rational numbers will always be same, will always be equal. Two equivalent rational numbers will always be equal. Now, let's try to understand why is that. So, I hope it's clear how when do we say that two rational numbers are same. Given two rational numbers, we do cross product, and we check the two products. If they are same, then the rational numbers are same. If the two products are different, then the rational numbers are different. Now let's try to understand why equivalent rational numbers are equal. So let's say I have a rational number p by q, and how do I get an equivalent rational number from this? I will either multiply both the numerator and the denominator with some non-zero integer, or I will divide. Let's say I am multiplying. So p into m q into m. So definitely these two are equivalent rational numbers. Equivalent, I am in short writing Rn. Rn means rational number. Rational numbers. Okay. Now to check whether these two rational numbers are equal or not, what we will do? We will cross product. Do cross product. Find the cross products. So this becomes p into q into m, and the other product becomes p q into p into m. You see, they are same. They are same. P q m, p into q into m, and q into p into m. They are same. This implies p by q equals to p multiplied by m divided by q into m. Now, this was when we created a equivalent rational number from p by q by multiplying with some non-zero integer. Let's say if I have a rational number p by q, and I created another its equivalent rational number by, let's say, by a number, a non-zero integer, which divides both p and q. Let's say we do p divided by m and q divided by m. Of course, here m has to divide both p and q. Now, so these two are definitely equivalent rational numbers. These two are equivalent rational numbers. Now to check if they are equal or not, we will do cross product. We will do cross product, and we see that p multiplied by q divided by m, and the other product is q multiplied by p divided by m. Okay, so what is this? P multiplied by q by m, and what is this? Q multiplied by p by m. Again, this is p into q by m, and this is q into p by m, and of course they are equal. P into q by m and q into p by m is of course same, because we know from multiplication of integers that multiplication is commutative. So p into q will be equal to q into p. So this implies that p by q equals to p divided by m divided by q. So we just try to understand that why equivalent rational numbers are equal. Okay, what else? Okay, the standard form of a rational number. What is a standard form of a rational number? When do we say that a rational number is in standard form? So a rational number p by q is in standard form when two conditions are satisfied. Number one, the denominator q is greater than 0, is positive, and the common divisor of p and q, the common divisor p and q is 1, meaning or p and q have no common divisor. Or we can also say that the HCF, the highest common factor of p and q, is 1. So let's see. So let's say we have a rational number, let's say 9 by 15. We are given a rational number 9 by 15, and we are asked if this is in standard form or not. So the denominator 15 is positive, fine. First condition satisfied. The second condition is that the HCF, the highest common factor. I hope you are aware. You know how to find the LCM. What are LCM and HCF of two integers? Now the HCF means the highest common factor, the highest factor that divides both the numbers. Now you can see the HCF of 9 and 15 is not 1, it is 3. HCF of, we know that HCF of 9 and 15 is 3, not equals to 1. This implies 9 by 15 is not in standard form. Okay. Now let's say 4 by 5. Here we can see, we know that HCF of 4 by 5 is 1 because they have no common divisor other than 1. So this implies 4 by 5 is in standard form. I am in short writing STD for standard form. Let's say minus 6 by 3, is it in standard form? Let's check. No, first minus 6 by minus 3, is it in standard form? Now you might say that the denominator here is minus 3, and so it is not in standard form. One second. Let's say you have a rational number minus 2 by minus 3. Now from the definition, as I explained, you will say that this is not in standard form because the denominator is negative, it's not positive. But actually this rational number minus 2 by minus 3 is in standard form. Why? Because there is a concept that if the denominator is if the denominator is negative, we can always multiply. We can always, for a rational number, if the denominator is negative, we can always have an equivalent rational number by multiplying both the numerator and the denominator by minus 1. In that case, the denominator will become positive. So this rational number, I can have its equivalent or equal rational number as, I will multiply this by this and this, and the denominator by minus 1. I will get an equivalent rational number which will be 2 by 3. So now 2 by 3 is equal to minus 2 by minus 3. Now 3 is a positive, denominator is positive. And now we see that here HCF of 2 and 3 is 1. This implies 2 by 3 is in standard form. So immediately, if you are given a rational number and if you see that the denominator is negative, don't immediately say that it is not in standard form. First you have to see that if you can have an equivalent rational number, you can always have an equivalent rational number by multiplying both the numerator and the denominator by minus 1. So in that case, the denominator will become positive, and it doesn't matter what is the numerator, it could be positive or negative. So this is the concept that in standard form of a rational number, we always have the denominator positive, and there should be no common divisor of the numerator and the denominator. I hope it's clear. When I will solve problems, it will be more clear. Now, the last concept is, if how do we express a given rational number in standard form? When you are given a rational number, two things can happen. Either the rational number given is already in the standard form, or you can always convert that rational number in standard form. So, given a rational number, how do we, if it's not in standard form, how do we express that rational number in standard form? So, the step number one is, let's say the rational number given is p by q. So, the step number one is that if q is less than 0, if q in the given rational number p by q is less than 0, then we simply multiply both p and q by minus 1. That will make q greater than 0, and whatever p becomes, that is not a problem. Next, we find the HCF of the numerical value of p and q. So, see, after the step 1, q is already positive. So, what is numerical value of a number? Numerical value of a number is the number ignoring its sign. So, the numerical value of minus 4 is 4, the numerical value of minus 5 is 5, the numerical value of 0 is 0, the numerical value of 4 is 4. So, in step 2, you find the HCF, the highest common factor of the numerical value of p and q. And if the highest common factor is m, you divide p and q by m. P and q, whatever p and q you got after step 1, you divide them by m, and the result will be a rational number in standard form. Let's say I have 10 by rational number 10 by 15. So, I can clearly see 15 is already positive. So, step 1 is not required. Now, step 2, I have to find the HCF of 10 and 15, and I know the HCF of 10 and 15 is 5. So, what will I do? I will divide both the numerator and the denominator by 5. Both the numerator and the denominator by 5, and this becomes 2 by 3. So, the rational number 10 by 15 has been expressed in standard form as 2 by 3. They are both same. The rational number 2 by 3 and 10 by 15 are both same, are equal, but 10 by 15 is not in standard form, whereas 2 by 3 is in standard form. Let's take another example. Let's say you have minus 6 by 4. So, the denominator 4 is already positive. The step number 1 is not required. Now, we have to find, in step 2, we have to find the HCF of not minus 6 and 4, but 6 and 4. Simply 6 and 4. The numerical value of minus 6 is 6 and the numerical value of 4 is 4. So, this is how much? This is 2. So, the next step is you divide minus 6 by 2, you divide 4 by 2, and this is minus 3 by 2. So, the decimal number minus 6 by 4 has been expressed in standard form as minus 3 by 2. Okay, I hope it's clear. So, that was all regarding the topics that I wanted to discuss in this video. Now, let's start solving some problems based on this topic from exercise 4a. Okay. So, now exercise 4a. Question number 7 2. So, the question is, find 4 rational numbers equivalent to the following. Equivalent to 4 rational numbers equivalent to each of the following rational numbers. So, it's asking to find 4 rational numbers equivalent to minus 3 by 8. So, what we can do? We can either multiply both the numerator and the denominator by some non-zero integer, or we can divide both the numerator and the denominator by some non-zero integer. Of course, that should divide both the numerator and the denominator. So, there could be lots of equivalent rational numbers for a given rational numbers, but you have to just write or create 4. So the rational equivalent rational numbers that you will create might be different from others, but that is no issue. You just have to multiply and divide or multiply with 4 different integers. So one could be I multiplied by 2, both the numerator and the denominator are multiplied by 2 and I get minus 6 by 16. So this is an equivalent rational number. Or let's say I multiplied by even, let's say minus 3 multiplied by minus 1, this gives 3 by minus 8. This is also an equivalent rational number. Or it asks for 4 equivalent rational numbers. Okay, so I will multiply by 3 both the numerator and the denominator, and I will get minus 9 by how much is 24. Okay, and the last one, let's say I multiply both the numerator and the denominator by 4, and I get minus 12 by 32. So these are 4 equivalent rational numbers of the given rational number minus 3 by 8. Okay, I think it will be very redundant, or the question, the part 3, 4 and first are same, so I will skip them. I mean, it's quite simple concept. You just multiply you either multiply or divide both the numerator and the denominator by the same non-zero integer, and you will get equivalent rational numbers. Let's do problem number 17. Write each of the following rational numbers in standard form. Okay, each of the rational number in standard form. First one is 35 by 49. So what are the conditions? How do we make a rational number in standard form? We first see that if the denominator is less than 0, it is not. So step 1 is not needed. Now we have to find the HCF, highest common factor of 35 and 49, which is 7. Then what we do in the second step, we divide both the numerator and the denominator by the HCF, and we get 5 by 7. So this is the rational number in standard form of the rational number 35 by 49. Okay. Next is 91 by minus 78. So first we find the HCF of, first we have to see that the denominator is less than 0. So we multiply both the numerator and the denominator by minus 1, so that the denominator becomes positive. So this is, we get minus 91 by 78. So we have made the denominator positive by multiplying both the numerator and the denominator by minus 1. Okay, and what is the next step? And the next step is we have to find the HCF of the numerical value of the numerator and the denominator, that is 91 and 78. Highest common factor, what will be? 7, no, not 7, highest common factor 3, no. I think there is the HCF of these two are 1 only, because 4, no, 3, 7, 9. Yeah, I think this is equals to 1. So we did not. So the next step was to divide the numerator and the denominator by the HCF, which is 1. So essentially, this is the rational number standard form of the rational number 91 by minus 78. I could be wrong, If I am wrong, I do not think there is any the HCF of 91 and 78 is other than 1. They do not have any common divisor, or do they have? 4? No, I don't think so. Anyway, okay. Let me know if I am wrong, if I am doing any calculation mistakes. Let me know in the comment section. I will appreciate that. Next is 8, 2, 9, 9 minus 161. So definitely the first, we see the denominator is less than 0. First we have to make that positive by multiplying both the numerator and the denominator by minus 1. We have to multiply both the numerator and the denominator by minus 1. This gives minus 299 divided by 161. Now we have to see, we have to find what is the HCF of 299 and 161. Does it divide by 7? So the 14, 3, yes. And what is, no, doesn't divide by 7. 3, no, 17. So 161, 11, 15 into 15, 161, 11, 1. What is the HCF? 299. Is there any number that divides both these numbers? Both these numbers. 3, no, 14, 14, 14 to 26, 3, 39, 3, 13, 13 divides 299, 13 divides 299, 26, 3, 3, and 13, does it divide 161? No. I'm not sure, I don't seem to find in divisor, common divisor of 299 and 161. I could be wrong. I'm assuming it's 1. So it is 299 minus 299 by 161. This is the standard form of the rational number 299 by minus 161. I could be wrong. There could be some common divisor. If that is so, if there is a common divisor other than 1 of 299 and 161, then we have to divide minus 299 by that common divisor and also 161. 4 minus 14 by minus 49. We can clearly see that the denominator is less than 0. So the first step is multiply both the numerator and the denominator by minus 1, and it becomes 14 by 49. Now we have to find the HCF of numerator and the denominator, and this is 7. So now we have to divide the numerator, both the numerator and the denominator by 7, and this is 2 by 7. So this is the standard form of the rational number minus 14 by minus 49. Okay, let's do 18. First one is fill in the blanks. Fill in the blanks. Minus 9 by 5 equals fill in the blanks, something by 20. Okay, now what will be, instead of fill in the blanks, I am writing what should be x. X should be an integer. What should be x? so that minus 9 by 5 equals to x by 20. Now, if these two are equal rational numbers, definitely we know by the cross product, this implies by doing cross product we should get minus 9 multiplied by 20 will be equal to x multiplied by 5. Now, this implies that from here we can find x. What will be x? Minus 9 into 20 divided by 5, and this is minus 36. Therefore, x is minus 36 equals to 36 by 20. So x is 3. X is 36. The first blank will be 36. Minus 36. Sorry, minus 36. Okay. Now, it is also given that minus 9 by 5 is also equals 27 by blank. We are considering the blank as x. We have to find x here. This is also given that minus 9 by 5 equals to 27 by blank. We have to find the blank, and I have considered the blank to be x. Now, if they are equal, if these two rational numbers are equal, by cross product we know that we must have minus 9 into x should be equals to 27 into 5. From here we know that x will be equals to 27 into 5 divided by 9. Now, if we cancel minus 9 and 27, we get by 3 we get this is minus 3. So this becomes minus 15. So x is minus 15. So this is 27 by minus 15. Second blank is minus 15. The first blank is minus 36. And it is also given that minus 9 by 5 is also equals to minus 45 by blank. I am considering at x. This implies if these two rational numbers are same, then by doing we will do cross product and we will equate the two products. So minus 9 multiplied by x has to be equal to minus 45 multiplied by 5. So from here we can say that x equals to minus 45 multiplied by 5 divided by minus 9. Now we can do cancellation. Minus 9 and minus 45 5, and this is 25. So x equals to 25. So this is minus 45 divided by 25. Okay. So 18 is done. Let's do problem number 19. Oh, so many questions are left. I see. State whether the pairs of following rational numbers are equivalent or not. Now, equivalent or not. Okay. Okay. So I will not do all. I will do only one, and you will understand the basic process. So it's asking whether these two rational numbers are equivalent or not. When we say that two rational numbers are equivalent, that when one rational number can be created from the other rational number by either multiplying or dividing with the same non-zero integer with the denominator and the numerator. Now clearly we can see that in the second rational number the numerator is 39, and in the first rational number the numerator is minus 3. So we have to now we see that minus from how so if they are okay, so we know that 39, we know that if you multiply 3 with minus 13 we get 39. So 39 has been obtained by multiplying minus 13 with minus 3. Now, but if we multiply 7 with minus 13, we get minus 91, which is not equals to minus 21. So, if these two rational numbers were equivalent, then definitely, if I multiply this rational number with both the numerator and the denominator of this rational number with minus 13, I get if I multiply with minus 13, I get minus 3 into minus 13, 7 multiplied by minus 13, this is 39 by minus 91. So, and 39 by minus 91 is definitely not equals to 39 by minus 21. So, definitely they are not equivalent. They are not equivalent. Let's do another one. Let's do the sixth one. 3 by 2 and 2 by 3. Now, another way to check whether two rational numbers are equivalent or not, you can also check whether they are equal or not, that is by doing cross product. But in doing cross product, remember that you have to do products. So, if the numerators and the denominators in the rational numbers are big, large numbers, it will be time consuming. But for small integers, if the numerators and the denominator of the two rational numbers are small integers, like less than 10 or something, then you can easily do the cross product and check. So, in this case, I can see that 3 multiplied 3 into 3, if I am doing cross product, 2 into 2. So, not 3 into 3 is 9 is not equals to 2 into 2, 2 into 2. This implies, so these are not equivalent. Let's see the last one, third one, 9 by 4 and minus 36 by minus 16. Now, here also, I mean, it's manageable, it's not that large, the denominators and numerators, you can easily do cross product and check. Now, if you do cross product, you get 9 multiplied by minus 16 over here, you will get this. Now, this is minus 144 and this is also 144 and they are equal. Therefore, these two are equivalent rational numbers. Now, I think so there are two ways to detect whether the two rational numbers are equivalent or not. Either you do cross product and you check whether the two products are same or not, or you see whether the in the rational number which has greater numerator is you can obtain that from the other rational numbers by multiplying with some integer. If so, then they are equivalent. If not, I mean, if let's say this was 9 by 4 and minus 36 by minus 16, I checked this whether they are equivalent or not by doing cross product. Let's say the other way, the other method, let's say I have 9 by 4. Now, in the second rational number, the numerator is minus 36. Now, I will first check how do I make the numerator of this rational number 9 by 4 minus 36. So, what will I do? I have to multiply with minus 4. Now, if I multiply with minus 4, I have to multiply. I'm trying to get an equivalent rational number by multiplying both the numerator and the denominator by minus 4. So, this becomes minus 36, the numerator, and the denominator becomes minus 16. So now I can see that this is the second rational number given. So they are equivalent. So this is another way you can check the two rational numbers are equivalent or not. Okay. Question 220 says find x such that. So this concept I have already discussed. It is saying that to find x when it is given that the rational number 13 by 6 is equal to minus 65 by x. Simply we do cross product and we equate the two products. So we must have 13 into x equals to minus 65 multiplied by 6. This implies x will be equals to minus 65 multiplied by 6 divided by 13. And so we can cancel 13 and 65 with minus 5. So this is minus 30. So x is minus 30. Okay. Let's do the third one. No, third one. Okay. 3 by 5 equals x by minus 25. If these two rational numbers are equal, then it is asking to find x. So two rational numbers are equal when we do the cross product and we equate and the two products are same. So in this case we will have 3 multiplied by minus 25. So we do cross product like this. So 3 gets multiplied with minus 25 and x gets multiplied with 5. So we must have 5 into x. The products must be same. Now from here we can say that x is 3 multiplied by minus 25 by 5, and if we cancel minus 25 and 5 we have minus 5. So this is minus 15. So x is minus 15. Okay. I will not do the question number 21 because it's asking whether the following pairs of rational numbers are equal or not. Okay, let's do I will do one. You will get the idea. Now to check whether two rational numbers are equal or not, there are two ways. The first way is you do cross product and see whether the products are same or not. If they are same, then the two rational numbers are same, and if they are different, then the rational numbers are different. The other way is that you convert both the rational numbers to standard form, and if the standard form of the two given rational numbers are same, then the two rational numbers are same. So since the numbers are a little big, I mean not so big, if you can do the products it's fine, but okay, let's say method 1 by doing cross product. So we say if they are we see 18 into 15 and we have minus 12 into minus 10. So this is, I guess, 120, and this is of course 120. These are equal. So definitely these two rational numbers are equal. This was method 1 by doing cross product. Now method 2, you apply the method whichever is convenient for you. So I am discussing both the method. I think if the numerator or the denominator, the integers are given large, then the product will take time. Now the method 2 is that you convert both the rational numbers to their standard form. So in this case 8 by minus 12, first what will I do? The first step, I am not writing in details. This is first step for converting a rational number to its standard form. If you follow the notes, this thing. So since the denominator is less than 0, first I will multiply both the numerator and the denominator with minus 1, and this will make minus 8 by 12. Now I have to divide both the numerator and the denominator by their HCF, which is 4. So I have to do minus 8 divided by 4, 12 divided by 4. So this becomes minus 2 by 3. So this is its standard form, and the minus 10 by 15, to convert this rational number to its standard form, step 1 is not required. So we will do step 2. This was step 2. In the step 2, we will divide both the numerator and the denominator by the HCF, that is the HCF of 10 and 15, and that will be, the HCF of 10 and 15 is 5. So we divide both the numerator and the denominator by 5, and we get minus 2 and minus 3. So they are same. They are same. The standard form are same. This implies that the two rational numbers are equal. Okay, I will not do the third one. I hope the process is clear. You can follow you understand the process, and you can apply it to solve any problem. Now, question number 22. These are conceptual problems, concepts that you must be very clear of. So, true or false statements. Every rational number is a fraction. Every rational number is a fraction is a false statement, because fraction is never negative. What is the definition of a fraction? Fraction is what? Fraction is P by Q, where P and Q are natural numbers. So P and Q can never be negative. Of course, P is not equals to 0. So P and Q will never negative. But we know that a rational number also includes the negative of fractions. So if so minus 2 by 3 is a rational number, because it is the negative of the fraction 2 by 3. But 2 by 3 is not a fraction. Is not a fraction, because fraction, as per definition of fraction, P by Q, P and Q are natural numbers, they are always positive. So first one is false. This is fifth one. Okay. 4. Every fraction is a rational number. Every fraction is a rational number. This is of course true. Why? Because a fraction is the number of the form P by Q, where P and Q are natural numbers, and of course every natural number is an integer, and natural numbers cannot be 0. So it automatically follows the definition of a rational number. So every fraction is a rational number. This is true. 0 is the smallest rational number. This is false. 0 is not the smallest rational number. Rational numbers can also be negative fractions, and there is no end to smallest rational numbers, because on the number line I can go to the extreme left. I can keep on moving to the left. It's endless. So there is no smallest rational number. Actually, the answer is there is no smallest rational number. 2. Every integer is a rational number. This is of course true. This is of course true, because every integer can be written in the form that integer divided by 1, and we see it is of the form P by Q. So every integer n, if n is an integer, we can always write n equals to n by 1, which is of the form P by Q. Of course, here Q is not equals to 0, and both P and Q are integers. So every integer is a rational number. This is true. Third, the quotient of two integers is always a rational number. the quotient of two integers is always a rational number. Remember that a rational number, the quotient of two integers is always a rational number. It is asking about the quotient. So if you of two integers, let's say p and q, are two integers, and it is asking when we divide q, let's say by p. Now let's see if this is true or not. So it's asking whether when you divide an integer by another integer, the quotient is a rational number or not. So meaning the quotient, whether the quotient can be written in the form p by q or not. It is actually false. It is actually false, because if you divide the integer 1 by 3, this is actually 0.3333, and is endless. There are endless number of 3's after 0. Now this cannot be converted to a rational number in the form p by q. And the quotient of two integers is always a is not always a rational number. So this is false. Okay. So I gave an example where the quotient is not a rational number, because in certain cases when you divide, there is a concept of actually it's a concept of non-recurring decimal numbers. It's a part of decimal numbers where when you divide an integer by another integer, you will have a decimal. The quotient will be in the decimal form, but after the decimal point, there will be endless digits. The digits will not end. So those cannot be expressed in the form p by q. So that was all. I hope this video was a little long. I'm sorry for that, but I hope this video was beneficial to you. And if it was beneficial, then please like this video, share this video with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by your future videos. The next video will be on the next topic of the rational numbers, which I guess is comparing rational numbers, and the next video will be on comparing rational numbers. So stay tuned for the next video. Thanks for watching, and until the next video, take care and bye.